In this video, I will show you why to use reliability-based design to assess geotechnical structures with ZSoil. There are lots of inherent uncertainties in geotechnical engineering, for example on ground parameters, on water level, on loads, etc. In a probabilistic framework, you can perform sensitivity analyses, which tell you which input parameters are most important, and then also reliability analyses, which tell you what is the probability of failure of your structure or the probability of passing a certain threshold. Therefore, risk assessment is possible. It also opens the door to Bayesian analyses, which is a formal and mathematical way of expressing the observational method. And then with real-time monitoring during the works, you can either optimize your design or reinforce it if needed. Everything will be present in the new Eurocode with guidelines on reliability-based design, which will be out in 2025. So say you have a finite element model. Here we have a tunnel. Instead of expressing the input parameters deterministically, you now define them as probability density functions, which can be Gaussian, log normal, uniform, etc. Then you perform a certain number of finite element computations, like for example 50 or 100. From that, you build a meta-model, which is a continuous approximation of the discrete model responses coming from the finite element calculations, allowing you to perform hundreds of thousands of computations in a matter of seconds. This, in turn, allows you to also express the quantities of interest in terms of probability density functions. Then, if you define a threshold, for example, a factor of safety smaller than 1, or a settlement larger than 25 millimeters, you can use the Monte Carlo simulation method in order to compute the probability of failure or the reliability index. And during the works, you can additionally use Bayesian analyses in order to refine this probability of failure, in case you have obtained new information about your project. This could, for instance, be a horizontal displacement measurement from an inclinometer. So in 2025, ZSoil will become ZSoil+R, where the R stands for reliability, and it will be powered by UQ Lab, which is a statistical toolbox developed at ETH Zurich by Professor Bruno Sudre, Dr. Stefano Morelli, and their colleagues. Here's a quick demonstration on the following example. We have a 4.5 meter deep excavation, and we would like to know the probability that the settlement behind the retaining wall exceeds 25 millimeters. Here you can see a 2D model of this example with 3 soils, and here you have the definition of the quantities of interest. These are, for example, a bending moment in the wall, and the settlement behind this wall when the excavation is completed. There is a new graphical user interface in ZSoil, allowing you to define the probability density functions of the input variables, here for the Young's modulus, phi, and the cohesion of the 3 soils, and for the water level. Then you can perform a sensitivity analysis, which in our case tells you that the material parameters of soil 2 are the most influential on the settlement. You can also consult the histogram of the settlement behind the sheet pile wall. It tells you that there is a probability of 20% that the settlement will exceed 25 millimeters. However, in case you decide to consider some measurements obtained during the construction works, here the horizontal displacement at the top of the wall just before the strut is installed, you can update the histogram. And you can see that after performing the corresponding Bayesian analysis, the probability of exceeding the settlement threshold goes down to 3%. So that is ZSoil+R coming in 2025, allowing you to perform reliability-based design on finite element soil structure interaction problems.